Hello, welcome to part 3. In the last video we created a reusable node called Rotate In for animations like these. In this tutorial we will create a nifty little subprogram in animation nodes for bounce in animations. Let's go! Alright, let's create some circles. So with the cursor in the center, can hide the camera so it's not in the way. I'm going to hit Shift A and create a mesh circle. I think I'm gonna turn up the vertices to 64 to have a very nice high detailed circle here. Now in edit mode, I'm gonna scale it up to, well, let's put a circle around here. Then extrude, S to scale, and create a ring like this. Okay, this is going to be our first circle. Of course it needs a material, so let's just take the same material, maybe, let's make a new one. Duplicate it and make it more green, glowing green. Turn down the strength a little. The bloom effect is quite heavy here, so let's dial that back a little. Okay, so now we have a green circle, but of course we want more than just one. So in object mode, I hit Shift D to duplicate it, go into edit mode, select all, scale them up, create a second ring, and then Alt D and select this ring in here, and maybe scale it up to make a thinner ring, like so. Shift D again, hit escape, go into edit mode, select them all and scale them up to create a third ring, and this third ring could be a little bit thicker, like, I don't know, like so maybe, and scale it out so we have the same distance. Okay, now let me just pick the camera. GC, what is happening? GC, move it up a little so that we have everything in the frame. All right. Now I'm even gonna go in here and give this the blue material just to make it look more interesting. So we have the green rings and the blue ring, the bluish ring. Maybe even make it more blue so that the effect is more visible. Now, the trick here for the sort of pop-up bounce-in animation is that we have to put these 3 rings into their own group. So I'm just gonna hit M, new collection, and call it, I mean collection, not group. They're now called collections. So let's call them big rings. Now we have a collection here. These 3 circles are in it. And now we're gonna go back to animation nodes and create our super duper pop-up animation. If you want to keep things organized in animation nodes, by the way, of course you can always create a new node tree here. So for example, we could select all of this, which is our reusable subprogram for the rotation animation, put it into its own node tree, and then still use it here like this. But I think I'm just going to keep it all in one node tree here for now. So let's create this pop-up animation. First, we need to get the rings, the objects out of this collection. So we take a collection info, we plug in our big rings collection, and then here we have the 3 rings. And this is what we're going to plug into our sub program. So let's create a subprogram. This is not a loop, it's just a group. We need an input, and that's gonna be an object list. Then we hit W, create invoke node, and we plug in our objects. So now here we have those 3 rings. Now, how can we bounce them in? Animation nodes comes with fall-offs and interpolation features that already give us the ability to create this bounce in animation. And of course, we're gonna just simply use that. So first we need the initial position, rotation scale of these rings. And we can always get that from the object ID key, initial transforms. So here we plug in our objects, and here we get an output of matrices, 1 for each ring. Okay, now the bouncing in effect we can simply do with a matrix offset matrix node, because here we can use the scale and we can plug in an fall off here. So here we have a list of matrices, and here we're going to create a fall off. And animation nodes comes with all sorts of cool fall offs. One is the delay fall off. And the delay fall off is perfect for this because it creates a delay for each of the rings. So if we have 3 in a group, the first one is going to bounce in, the second one is going to bounce in, and the third one is going to bounce in. The bouncing can just be done with setting this to back, which already shows us here in this little icon that it's a bounce. And we want to bounce at the end. So this, we have to activate this. We don't need to bounce at the beginning, we just bounce at the end. Okay, now we plug this in here. And what do we actually want to offset? We want to offset the scale, and we want to offset it so that it bounces in from a scale of 0, basically. So pretty soon, I hope this is going to become a little clearer what is happening. Now, with this offset matrix, we're not actually changing any object yet. We have to, let me just push this down a little. What is happening? We have to use a matrix, an object matrix output node. So we want to actually scale those objects using this matrix. Now let's see what happens. Nothing happens. Why? Well, because we're not even using any animation yet. We have to plug the time in here first of all. So let's get the time information node, plug that in here. And then also we have to set the delay and the duration. It comes with default values, but it already works. So starting here, wow, they're bouncing the wrong way. They're big at the beginning and then they bounce to the scale 0. That's not what we want. We want to invert this fall off. So they come in from scale 0, from nothing basically, and they bounce in to their final position. Now ignore those rotation animations in the middle here for now. Let's just look at the rings, the circles here. What are these values? We wait 5 frames and the bounce in duration is 20. So the first one starts right away. It comes in and it takes 20 frames to actually reach its final location. Okay? 5 frames in, so here on frame 6, because it's a delay of 5, the second ring comes in, the second object of our collection. And it takes 20 seconds to reach its final location. And then the third one comes in. So we need to be able to change these values in our reusable subprogram. So easy peasy, we can just plug them in here. Take an integer, call it delay, take another integer, and call it duration, and then connect this up, delay, duration. Okay, cool. So now we can set it out here, and if we reuse this, we have control out here now. Right, now, just like with our ring animation, with our rotation animation, we want to offset this animation a little. We don't want it to start at frame 1. Of course, now we have to set the delay to 5 and the duration to 20. Otherwise, nothing happens. Okay, so we want to offset this. Maybe we want this whole ring animation to appear at frame 10, not at frame 1. So I want a frame offset. Wait a second, what did I call it over here? Rotation offset, start frame, end frame. Let's call it start frame. Let's call it an integer. Let's get an integer in and call it start frame. Okay, now we have to use this start frame. Let's move all of this back here and simply take a math node and add our start frame to our time. Use that for the time. So add, no, not don't add, subtract, of course. So if I set the start frame to 10, now the bouncing in the first ring should start at frame 11. Cool, it works. Okay, so now we have a reusable subprogram where we can set delay duration and a start frame. Let's see if this is actually reusable. How do we do that? Well, how about we simply take those 3 circles, Shift D, escape, then scale them down, place them in here, and move them to a new collection called small rings, maybe. Okay. Now, of course, we can go in here, maybe, scale this one in, scale this one in, but we have to apply the scale. That is important since we're messing with the scale in here. So make sure that over here the scale is 1 on these rings. Okay, if you want to edit them, you have to do it in edit mode. Let's do something like this. Okay, now let's duplicate these 2 nodes. Instead of big rings, we want the small rings. We want to start at frame 100, a delay of 10, a duration of 30. I don't know if this looks good. Let's see. Okay, at frame 101, this first ring starts to appear. The animation is quite slow, and then all 3 rings appear. Very nice. So we've reused our subprogram. First use is up here. Second use is back here. Very, very useful subprogram. How can we improve it? Well, we have this scale 0 here, for example, which means we're always coming in from a scale of 0 and we're bouncing to its final scale. So maybe we want to be able to set this from outside, from here. So I don't know if it's any useful, but how about we just add a new float here, call it scale, create a vector, combine a vector, Where do I put this now? Whoops. Maybe here. Take the scale 3 times and plug that in here. Okay, so now we have this parameter out here as well. And 0 is what we use by default because we want them to bounce in from 0 size. Now if we don't want them to bounce in from size 0, maybe they should be only bounce in a little. We could say, let's start at 0.5. Okay, so they start at size 0.5 and then they bounce into their final full size. But again, we have the same issue as with the lines and dots in the first video. They're always visible. We only want them to be visible at or starting at start frame. Okay, so we have to use our visibility trick again. So object visibility output, take those objects, enable the hide viewport and hide render here. When do we hide them from the viewport and the render? Let's see. What do we have here? We calculate the fall off, and basically if this fall off, you can think of this fall off as a value between 0 and 1, except that it can go below 0 and above 1 because of this bouncing effect. Now we can't really calculate anything with a fall off data type, but we can convert a fall off. We can evaluate the fall off, right? So we take the fall off, we have to make a list. How many evaluations do we want? Since we get a list of objects here, we have to take a get length node here. Where can I put this? I don't know, just put it here. There's all sorts of lines crisscrossing here, just ignore that. Okay, so we evaluate each of the fall-offs of the objects, and then we have a strength here. So we have a value here that we can actually use in a calculation. How about we compare it, and we say if this value is less than or equal to 0. Okay. Now we can't just say 0 here because we're plugging a list in. We're gonna have to create a list of zeros. Create a list, create float. That's not really very usable, is it? So we're gonna do something completely different here. We have a list of objects and we have an evaluated fall off node, and we're just going to plug this into a tiny little inner loop. So inside of our subprogram here, we're going to create another loop, so another subprogram, where we take a list of objects and we take a float list. Now let's invoke this subprogram. This is the list of objects. This is the list of our evaluated fall-offs. And inside of this list now we can do a compare, Boolean compare. Let's say if, let's see, if our fall-off is less than or equal to 0, cool, then we have to hide. Whoops, that's then we have to hide this object from viewport and from render, and that's all this loop has to do. Let's see if it works. Nope. Oh, they hide. Oh, because I'm using this fall off. I have to use this fall off, not the inverted one. This inversion here is just so that they bounce in instead of out. Okay, Cool, they're not visible, so the inner rings, outer rings become visible at frame 10, 11. As soon as the fall off is actually doing something from this delay fall off node, and then it stays visible. And then the inner rings that start at a size of 0.5 become visible at frame 100. They bounce in and they stay visible. Very nice. So with this new subprogram with a little tiny inner loop, we have another very useful and reusable subprogram for these kinds of bouncing in animations.
How is it going, guys? Are you following along? Have you made any cool looking sci-fi UI graphics using animation nodes yet? We all want to see, so please post your art on one of these platforms. In the next video, we will try to create another reusable node. The goal is to place a number of graphical elements around a circle and have each one of them bounce or flash in. I hope you join me in part 4. Like, comment and subscribe for upcoming animation nodes tutorials. And by the way, you can already find many more on my channel. Thanks for watching. See you in the next part. Crispy out.